Today we're going to talk about finding the area of a regular polygon. With polygons, remember, this is shapes that have multiple sides. They're closed, they're plane. We're talking about the regular ones, which have all the sides and angles equal or congruent. When we're talking about the polygon, it has a center. Like anything else, it's the center. The center of a polygon is equidistant from the vertices. And so this center here, if I draw a line to each of the vertices, that's going to tell me that all of those lines from the center to the vertices are congruent, as you see I've marked them with congruent, and that center is in the very middle. The apothem, however, is the distance from the center to a side. So the distance from a center to a side. So this dotted line here that I'm drawing is the distance from a center to the middle of a side. Notice it forms a 90-degree angle here. So I actually have an apothem for each side. And I can label that with an A for the apothem. So that's dividing these triangles into halves. The central angle of a polygon has a vertex included with it. So a central angle is it has a vertex at the center and extends to two consecutive vertices. Okay, so it extends to two consecutive vertices. That's how this works. So, for example, FCE is an angle FCE. So this one right here is a central angle. It has an angle, the vertex is at the center. When we go up here and we look at what it means to have a regular polygon, and we're going to find the area is based on each of these individual triangles. And so if I draw this in, and I draw in this apothem here, notice it goes from the center to the middle of a side. The regular polygon's area is based on each of these triangles that is formed. Okay? And so the area of each triangle equals 1/2 of the side length times the apothem, right? Because of this triangle here, it's 1/2 base times height. Well, the base is the side length. The apothem is the height. So that's the area of each triangle. Well, how many triangles are there? There's one triangle for each side. So the area of the polygon equals the number of sides times the number of triangles, and each triangle is 1/2 times side times apothem. So I have n times 1/2 times side times apothem. Well, if I multiply the number of sides by the side length, that's the perimeter. So I have a side here, side here, side here, side here, side here, side here. The number of sides times S is the perimeter. So really, these multiplied together is going to be 1/2 the apothem times the perimeter, because the perimeter is giving me the total amount around. Well, it's 1/2 apothem times perimeter. That's the formula for the area of this regular polygon. When I go over here to this example, I'm going to find the area of a regular polygon with side length of 6 meters. If this is 6 meters, this apothem drops down and each of these is 3, and you see I have that marked down here. Alright, so I have 3 meters marked right here. Well, that gives me a triangle with 6 as the hypotenuse, 3 as the base. Now remember, this is half of this. And so this is going to be 3 square root 3 here, because it's based on the amount of angle degrees in each of these angles. If I'm going to find the 1/2 the apothem times the perimeter, that's going to give me 1/2, and the apothem is 3 square root 3, and my perimeter is going to be 6, 12, 18, 24, 30, 36. So my area is 18 times 3 square root 3, which gives me 54 square root 3 units squared. We went a little bit fast there. That's if they're giving you the apothem. Let's look at one more example. One more example. If I have a regular pentagon with side length of 8 inches, let's look at what this means. If I draw my pentagon out here, and I know that it's regular, watch what I do. I'm going to draw in this bottom central angle, but I'm going to know that I have other central angles here. How many degrees are in each central angle? Well, I have 1, 2, 3, 4, 5 central angles. So central angle is going to be 360 degrees divided by 5 total angles is going to give me 72 degrees. If there's 72 degrees in each of these triangles, notice what it looks like. It looks like this. I've got 72 degrees here, and I have the apothem. This is this triangle here. And the side length is 8 inches. So that means this down here, total, is 8 inches. Let's find the area of this triangle. If I have a 72 degree angle and I drop that apothem down, it divides this triangle into 2 congruent triangles. So this over here is 36 and this is 36. Notice what happens. This is no longer going to be just a 72 degree angle. It's going to be 2 36 degree angles. And look what happens. I need to find the apothem. And so I have this little triangle that I've pulled out here, which is 4 on the bottom, because this total thing is 8 inches, so it's 4 each. So this is 4 on the bottom. There's a 36 degree angle here, and I need to find the apothem. I have a right triangle with one other angle given, and I need to find the apothem. I need to use trig ratios. If I use trig ratios, watch what happens. Opposite over adjacent. The tangent of 36 equals 4 over a, multiply by a, divide by tangent of 36. So a is equal to 4 over tangent 36. I'm finding the apothem. A lot of this chapter is about this problem-solving process of finding the pieces that I need. And so if I've found the apothem, I just plug it into my equation. The area is 1/2 apothem times perimeter equals 1/2, and the apothem is 4 divided by tangent 36 times the perimeter. Well, if this is 8, and this is 8, and this is 8, and this is 8, and this is 8, the perimeter is 40 because it's a pentagon with 5 sides at 8 inches apiece. So I have 20 times, and I'll scroll up a little bit, 20 times 4 over tangent 36. I'll plug it into my calculator. 4 divided by tangent 36 times 20. And I'm going to round to the nearest tenth when necessary. And this gives me a total of 110 110.1 units squared, and it's in inches, so it's 101 inches squared. 110.1 inches squared. Find the apothem. Once you have the apothem, you can find the amount of degrees, or you can find the amount of area covered by the polygon. I want you to try this one. Come to class with questions, guys. Let me help you out. 1, 2, 3, 4, 5, 6, 7, 8. This is what it's going to look like. I have a triangle here, side length of 4. So let's divide this triangle up right away. Boom, boom, boom. Here's my apothem. I know that each of these is going to be 2. And I have a problem here because I don't have any degrees in this triangle. So the triangle that I'm solving for the apothem looks like this. And I need to find this degree measure here. Well, if there's 8 angles, it's 360 divided by 8, which is going to give me 45. And then that's half of 45, which is 22.5. So this central angle is 45. And I'm dividing it with the apothem in half, so it's 22.5. See if you can solve for the apothem and then solve for the area. That's my hint to you. All right? Come to class with questions tomorrow. We'll do some more examples, then we'll work it out. All right, guys? Thanks for watching. We'll see you next time.